Hi everyone, welcome back to this channel. In today's video, we'll learn about partial order and total order. So if you enjoy the video, like this video and subscribe to this channel. Okay, so let's start the topic. So what is the partial order? Partial order means it is actually a binary relation. Okay, which is reflexive, antisymmetric and transitive. So we already know about reflexive, antisymmetric and transitive. That is, if suppose this is the relation, okay, and every element is related to itself, that then we say that relation is reflexive. And for antisymmetry, if A and B, two elements of the set A, and if A is less than or equal to B, and if A related to B and B related to A implies A and A equals to B, then we say the relation is antisymmetric. And for A, B, C belongs to A, if A related to B and B related to C implies A related to C, then we say the relation is transitive. So if a binary relation is reflexive, antisymmetric and transitive, then we say that is a partial order on a set A. Okay, and what is a partial order set, or in short set? It is actually a pair. Okay, it is a pair of a set and a partial order defined on that set. Okay, so let's understand this with some example. Suppose the binary relation less than or equal to on the set of a real number. Okay, so it is clear that for every element, for every real number, is less than or equal to itself. Okay, so A is equal to A, so it implies A related to A. Similarly, if A less than or equal to B and B less than or equal to A, that implies A is equals to B. That is obvious. And if A related to B and B related to C, if A less than B, less than or equal to B and B less than or equal to C, that obviously implies A less than or equal to C, which is transitive. So the binary relation less than or equal to on the set of real number is a partial order. Similarly, the relation subset, subset or equal to on the set of set, that is on the power set of S, is a partial order, because it is obvious that X is subset or equal to X. Okay, so that implies X related to X, which is reflexive. And if X subset of Y and Y subset of X, that implies X equals to Y. Okay, which is the condition of equality of set, that implies, which is antisymmetric, that satisfies. And similarly, if X subset of Y and Y subset of Z, then implies X is subset of Z, so which is transitive. So this is also a partial order on the set of subset. Okay, so now we understand what is the condition of comparability. So in a partially ordered set, if every two elements are related with the partial order, then we say the partial order, then we say the set each, then we say the every element are comparable. Okay, then we say every element are comparable. For example, in the set of real number, with the relation less than or equal to, we can relate every two element. Okay, for example, 5 is less than or equal to 6, or 7 is less than or equal to 9. Similarly, any two element can be related with this less than or equal to relation. Okay, but in case of set, in case of subset, if I consider these two subset, these two subset of S, which I cannot relate these two sets with this subset of equal to relation. Okay, so the relation subset of equal to, so these two kind of elements are not comparable. Okay, so this subset of equal to relation is not, you cannot use this as a comparability condition. Okay, So now we define total order. Okay, so what is total order? Any partial order set where every element are comparable is called a total order set. Okay, so every partial order set where every two element are comparable is called a total order set, and we denote like the partial order set, that is A with this relation. Okay, this partial order, and this relation is called total order relation. Okay, so every partial order set, every partial order relation where if every two element are comparable with this partial order, then we say that relation is a total order relation. Okay, if this partial order, with this partial order, we can relate every two element of the set A, then we say this is a total order. Okay, and the order and the pair A with this total order is called a total order set. So from this above comparability example, we clearly know that is the less than or equal to is a total order relation because it is comparable. Okay, and partial order, so it is total order. That actually means comparability. So partial order plus comparability condition is equals to total order. So we can compare any two element, any two real number with this relation. So this is a total order. But we cannot compare any two subset with this any two sets with this subset condition. So this is not a total order. This cannot satisfy comparability condition, but this satisfy. So the set of real number with less than or equal to is a total order set, but this power set which subset of equal to is not a total order set. Okay, so this is all about partial order and total order. If anyone have any doubt or query, please comment. Okay, thank you.